Okay, so today we are going to learn about the equations of motions. There are 4 equations of motions that we are going to learn today, and we'll follow the book. I'm showing you which book we are going to follow. Just a minute. We are going to follow this book, Cambridge Physics for the IB Diploma, 6th edition. Okay. So we are going to see 4 equations of motions. Just a minute. Very beautifully it is explained here, and that I will elaborate to you in very simple language. Okay. So we are going to talk about the uniform motion. Uniform motion means when the velocity is uniform, it is constant. And then we'll come to the uniform acceleration. And we'll do it graphically. Okay, see here. We are going to see all the 4 equations of motions graphically. Graphically, how we can derive it, that I'm going to show you. That I will teach you today. So this is uniform motion. In uniform motion, the graph of position versus time is a straight line, isn't it? So on y-axis, we are taking position of the body, and on x-axis, we are taking time. Correct? So when we draw the graph, what we find? We find a straight line. We find a straight line. So see, this is the position when time is equal to 0. Okay? And just imagine that this is your S. This point is S. This point is S. Correct? So draw a perpendicular from here on the time axis. So this is your T. Here T is equal to T. Okay? Here T is equal to 0. This is your S. S means draw a perpendicular from here. So this is your S. Correct? This is your S. Yes. So what is the coordinate of this point? The coordinate of this point is T and S. Correct? First of all, we write the X coordinate and then we write the Y coordinate. X coordinate of this straight line is at this point. Just assume that this point is P. So at point P, the X coordinate is T and the Y coordinate is S. So this is your T, this is your S. And this is at T is equal to 0. This is your SI. SI means the initial position. This is the initial position of the body, and this is the final position of the body. Okay. So what you see here, so how will you find this? S. You already know that the body, initially the body is at initial position. Initial position is equal to SI. Final position of the body is equal to S. And the body is moving from SI to S with uniform velocity. Okay. So that velocity, we can assume that that velocity is u. Is the uniform velocity. Correct? So, or this you can write a v also, either u or v, no problem. V. Meaning from here to here, the body is moving from this position. This position is A, from A to P with uniform velocity, that is v. Okay, and initially the position of the body is SI. Correct, means initially the body is not at origin. Initially the body is having some displacement, and that is SI. So it means, and it means in time t, here the body starts its journey. So what is the time here? 0. So from 0 to 2, 0 to t, if the uniform velocity is v, then in time t, what distance, what displacement the body will cover? So what is that? You know that is v into t. V into t. So you can write this: S is equal to initial position of the body is SI plus what distance it is traveling in t time? V into t. Correct? Or how we find it? See here. We know that in a displacement time graph or in a position time graph, the gradient of the line, gradient means slope. So gradient of the line is, gradient is equal to, that is equal to v. What is v? V is equal to delta S upon delta t. What is delta S? That is change in position. That is S minus SI. What is delta t? Change in time. That is t minus 0. So we can write it as v is equal to S minus SI upon p. That will become S minus SI is equal to Vt. Correct? Means S is equal to SI plus Vt. We got it. Correct? So this is your first equation of motion. S is equal to SI plus Vt, where S is the final position, SI is the initial position, V is the uniform velocity, and T is the time. Correct? Now we are going to derive other equations of motion. See here, the same thing. V is equal to S minus SI upon T minus 0. That is S is equal to SI plus Vt. And you are already knowing that displacement is the change in position and distance is the length of path followed. Means this is the actual distance. This is the actual path. And this is the change in position, means final position of the body minus initial position. Always remember, final position of the body minus initial position. Okay, final position minus initial position. Displacement is a vector quantity. You already know direction is very, very important here. And distance is a scalar quantity. Okay. If there is a question, just see here, a motion in which the particle changes direction, and here the particle does not change direction. So here, if particle starts, the initial position of the body is -4. What is the final position of the body? 16. So what is the distance traveled? Distance will be from here, it is 4, and then it is 16. So 4 plus 16, 20. Distance is equal to 20. If it is in meter, you can write it is meter. And what is the displacement? displacement is final position of the body is what? 16. Final position minus initial position. So final position of the body is 16. Initial position is final position minus 4. So that is 16 plus 4. That is 20 meters. So here, in this case, because there is no change in direction, so distance and displacement both are same. Okay, but here, see here. Here, the initial position of the body is 12. And final position of the body is 4. Okay, so as I told you, distance is what? Distance is the actual path. So actual path, this is the actual path. The body comes from 12 to 20, and then it changes its direction, and then it comes to 4 from 20 in negative direction. Okay, but because the distance is a scalar quantity, so we did not bother about the direction part or sign part, negative or positive. So what is the actual path the body has traveled? This is 20 minus 12 is 8. This is 8. And this is 4 minus 20, means that is minus 16. We are concerned about only the magnitude. So we'll write here 16. Isn't it? So this is 8. And this is 20 minus 4 is equal to 16. 16 plus 8 is equal to 24. So this is your distance. Distance is equal to 16 plus 8 is equal to 20 meters. But for displacement, what is the displacement? Just remember the formula. Always you have to apply that. Displacement is equal to final position minus initial position. Final position minus initial position. What is the final position? 4. What is the initial position? 12. Final position is 4. And then minus 4 minus 12. So that is equal to minus 8. Correct? Minus 8 means here initially the body was going towards right, but finally it has reached in the left of that, and finally it is at 8 meters away to the left. So that is minus 8 meters. So here direction is sign is very, very important. So in case of if you draw the graph of velocity versus time graph in uniform motion, means when the velocity is constant, so you will get a straight line parallel to time axis. You will get a straight line parallel to time axis. Correct? So this is the velocity time graph. On y-axis you are taking velocity, on x-axis you are taking time. So because velocity is uniform, so at any moment you can find that this velocity is same. So it means it is constant throughout the journey, means this line is parallel to the time axis. Okay. Now, so we already we know that if this is your displacement on y-axis and time on x-axis, then if this is your graph, then the gradient of this line will give you the velocity. Okay, that is equal to v is equal to delta s by delta t. Similarly, if a body is moving with uniform acceleration, that is a is equal to acceleration, and that is uniform also, means acceleration is not changing, velocity is changing. Okay, but velocity is changing at a constant rate. Velocity is changing but at a constant rate, means that this is uniform acceleration. So just like here, we get from ST graph, we get the gradient, the velocity from the gradient. Here also from VT graph, the gradient of the line, a straight line, will give you the acceleration. So here we'll get A is equal to delta V upon delta T. Okay, see, both are similar. So your delta V means what? If final velocity is V, initial velocity is U, and delta T, if this T minus 0, so that is V minus U upon T. We can write A is equal to V minus U upon T. Means this will become V is equal to U plus AT. This is your first equation of motion. Okay, so this is very important. See here, A is equal to V minus U upon T. Correct? You can also write T is equal to V minus U upon A. See, T is equal to, by cross multiplication, T is equal to V minus U upon A, and that we are going to use. It depends on the question. We are going to use all the three forms of this equation. Means V is equal to U plus AT, A is equal to V minus U upon T, and T is equal to V minus U upon A. Correct? So we are talking about uniformly accelerated motion. Means here the velocity is not constant. Velocity is changing, but velocity is changing at a constant rate. Means acceleration is constant. See here, V is equal to U plus AT. So this is your first equation of motion. We have already derived it. Now, if we know see in this, if this is a velocity time graph, this is a velocity time graph. On y-axis we are taking velocity, on x-axis you are taking time. So this U, when the time is 0, means when the time is 0, the initial velocity is U, and when the time is t, the final velocity is V. So what is your U is equal to initial velocity. And V is equal to final velocity. Correct? And here the velocity is changing at a constant rate. Means A is uniform acceleration, you can say. What is the time of journey? Time of journey T is equal to total time of journey. Okay. So what you can write it here? You see here, from here. So if somebody tells you find the displacement, what is the displacement? So from the VT graph, the area under the curve, means this area will give you the total displacement. Okay, area under this is a trapezium. Can you see the shape? This line, and this line, this line. This makes a trapezium. So what is the area of the trapezium? Means that will give the displacement. Area of trapezium is half into sum of parallel sides into perpendicular distance between parallel sides. Distance between parallel sides. So you can write, here you can write delta S is equal to half sum of parallel side is U plus V, or V plus U you can write. Okay, V plus U, just a minute. u plus v multiplied by t. Correct? So this gives you finally u plus v by 2 into t. Correct? This is your one equation. This is another equation of motion. And this is only applicable when a is constant, uniform acceleration. Okay. Next. Now see here from the same equation we have already got this delta s is equal to u plus v by 2 into t. So we have already derived that v is equal to u plus at, which is first equation of motion. Correct? So here in place of v, you can write u plus at. You are replacing this v. So we can write u plus at upon 2 into t. Correct? So this u plus u, this will become 2u plus at by 2 into t. Now you write it separately. 2u upon 2. Okay? 2 will be cancelled and then multiply with t. It becomes ut. Plus this is at into t, at square, and at by 2. At by 2 into t square means half at square. This is also equation of motion. So earlier one was the first equation of motion. This is the second equation of motion. Okay. And if ut plus half at square, but if there is some initial displacement, in that case, delta s is equal to ut plus half at square, means the body does not start its journey from origin. If initially there is some displacement, in that case, delta s is equal to s minus si, means s is the final position, si is the initial position, is equal to ut plus half at square. So you can write s is equal to si plus ut plus half at square. Okay. So this is your second equation of motion. Okay. Now we are going to derive the third equation of motion. See, we already know that delta s is equal to u plus v by 2 into t. Correct? And now we already know that from the first equation of motion, v is equal to u plus at. We can write t in form of v and u, means t is equal to v minus u upon a. Can we write? Yes, we can write. So here we'll put this we are writing v plus u upon 2 multiplied by v minus u upon 2. So this becomes a plus b into a minus b. V plus u into v minus u. This becomes v square minus u square. V square, and this is your a, not this is your a. V minus u upon a. See here, t is equal to v minus u upon a. So v square minus u square upon 2. Correct? Finally, this equation will, here it is delta s. Finally, this equation will become v square, or you can write it like delta a. Fine. Just a minute. So this you can write it as v square minus u square is equal to 2a delta s, or v square is equal to u square plus 2a delta s. Correct? So if the body does not start its journey from the origin, means there is some initial displacement, means the initial position of the body is SI and the final position is the S. Then in that case, V square is equal to U square plus 2A into S minus SI. Okay, so this is your third equation of motion. This is the third equation of motion. Generally, we call it third equation of motion. This is the second. This is the first, and the fourth equation of motion, from which you are deriving all the other equations, the second and third. This is called fourth. Okay, you can you have to know that there are four equations of motion. Anyone can be 1, 2, and 3 and 4, but this is the first. Okay, first equation of motion is V is equal to U plus AT. Second equation of motion is SI plus UT plus half AT square. Then third equation of motion is V square is equal to U square plus 2A into S minus SI. And the fourth equation is delta S is equal to U plus V by 2 into T. Correct? These are the four equations. But when these formula can be used for constant acceleration only. Correct? So whatever the formula we have written means V is equal to U plus AT and delta S is equal to UT plus half AT square, means S is equal to SI plus UT plus half AT square, and then V square is equal to U square plus 2A delta S, means V square is equal to U square plus 2A S minus SI. Okay, and the fourth one is delta S is equal to U plus V by 2 into T. So see here, if SI is equal to 0, initial position is equal to 0, if SI is equal to 0, if SI is equal to 0, means the body starts its journey from the origin. In that case, what will happen? In that case, everywhere it will become 0. Okay, this will also become 0. So your equation will be reduced as follows. Means your equation will be like that: V is equal to U plus AT, which we already studied in the class 9-10, and S is equal to UT plus half AT square, and V square is equal to U square plus 2AS. Correct? And this is S is equal to U plus V by 2 into T. And this is only possible when your initial position is 0. Means SI is equal to 0. If SI is not 0, SI is having some value, in that case, this is the complete equation. Okay, so both the equations you have to know. It depends on the problem, what is given in the problem, and then according to the problem, you have to apply this formula and solve the problem and get the solution. Okay, so for today, this much only. In next class, we'll do some problems on these equations of motion. Okay, so we'll meet in next class. So I will stop sharing. Okay, we'll meet you in next class.